so much for being here this morning just to attend this presentation, this public presentation. My presentation is entitled Improvement of Multimodal Deep Learning, Predictive Models for Electronic Health Records. This is the outline of this presentation. I will introduce my work through a background, but also talk a little bit about my research motivation before talking about my main contributions. And I will end my presentation with a conclusion and talk a little bit about some limitations. Introducing this work, artificial intelligence, like in any other domains, is greatly impacting medical field. And this evolution has been made possible by a good combination of computing power, the availability of data, but also the algorithms. The data is being collected by tools such as electronic health record for medical area. And in 2019, there was a book named Deep Medicine that was trying to compare the diagnostic accuracy between AI-based systems and human being, where they show that the accuracy of diagnostic from doctors who have human experience is about 84%, while machines could only go up to 51%. And this is mainly due to the fact and the structure of electronic health records. The electronic health record systems have structured medical data, semi-structured medical data, but also unstructured. And finding a good way of combining this information with all the complexity, diversity that comes with it, and also in consistent format, present a big challenge for machines and AI algorithms. We need to find a better way of data mining, but also of designing machine learning specifically for medical area. And as an example, this is an example of a patient from our data set. The data set we use for this research is a MIMIC 3 version of a publicly available data set. And this patient was admitted for cardiac arrest from community. And he survived and was discharged to home after 12 days. And within those 12 days, you can see how much information have been collected on that patient. Data from different sensors, but also medicine that have been administered to the patient, but also a lot of other information collected gradually and every single day of his stay. And this kind of information usually, when a doctor is visiting that patient on his bed, most of the time he uses information written on notes. Those notes are left by different experts, different teams, and by combining that kind of information, reading what is written, he can infer and understand the status of the patient. And that kind of understanding of the patient is the key where we try to mimic the same behavior for machines. And as you can see, this is a work that was published last year. It shows how machine learning models, especially language models, that are trying to mimic the behavior of a doctor are kind of like struggling with, for example, combining sparse, dense text representation, such as, for example, the sparse representations such as TF-IDF bag of words and others, but also a combination of deep neural network, but also traditional ensemble models. And this shows the challenge that is posed by medical data, but also in general, but also how we can find the best way of representing a patient using all the information that is available and collected from that same patient. And because of that, our idea was to kind of divide our work through three main stages. First, we need to find a way of mining data, but also the design of the model, and try to find a way of optimizing the new model. And current predictive models have challenges to understand medicine, as I already just mentioned, but also predictive deep learning for biomedical and clinical area have specific need, as already mentioned. And those needs are or can be divided into data mining, as already said, model designing, but also adaptation of model machine learning tools to the domain or the area through some fine-tuning, for example, of hyperparameters, but also tools such as tokenizer. And this also has to be or has to consider the structure of the data. We've seen that unstructured data need specifically NLPs, but also structured tabular medical data can also be transformed or can be explored as they are through different data mining techniques. But we also have to consider clinical images, which will also need a specific model designing. And because of that, our first contribution in this area was to start by a study which will show the best combination of data mining, data mining, data processing, but also the text representation through embeddings. We've done this research first because we wanted just to kind of have a good idea of what is the best combination that will lead to the best result in terms of prediction of patient outcome. And through this, we've able to provide a kind of benchmark for the future research, including ours. And talking about ours, our second contribution also was to address the problem of tabular data. The tabular data has to be transformed. This was our idea to think about transforming these tabular data into text so that it can be analyzed and combined with the first research or the first approach of taking text notes. And this novel data transformation based on fuzzy logic was basically a simple way of transforming data through ranges. And we used already published papers and research to find ranges that can be assigned to each category and each membership for different diagnoses and different values. Our third contribution, talking about the second contribution, we've noticed that this approach has a huge impact in terms of explainability. The explainability in AI and in medical area specifically is a huge deal in terms of being able to understand what the machine is predicting. Through this example, we've been able to see or to realize that the text that we've generated through that transformation was able to find the cause of death in a natural language text. And this red signs right here shows actually the main weight from this text, which was the main cause of the death of this patient. While in this discharged patient, we've also been able to understand that respiratory censure was not a big, a later, let's say, cause, but also having a patient with asthma, for example, and with acute bronchitis asthma can be a positive sign of his survival. And our third and last contribution was to improve the language models that are used for medical area and patient understanding. We've done this research so that we can have a chance to improve or to increase the embedding size of traditional language models. We use sparse attention here to improve the language model's capability to handle 8 times the previous state-of-the-art models, including BERT and others. And not only this, we've also been able to train our tokenizer based on a BPE subsystem, and we've been able to increase also the embedding, the tokenizer size, where we adapted this tokenizer to medical area, which has a huge impact in terms of understanding medical terminologies and what need to be also embedded together with the medical annotations. And as a global contribution, this is the result. From the second chapter, we've been able to prove that having bird-based model can have a huge impact of almost 10% of improvement, and also a thoroughly cleaning can also improve the result by 6.94%. And as already said, we've been able to improve the interpretability through the data transformation, but also we've been able to improve state-of-the-art in terms of named entity recognition, region extraction, and also others, such as Q&A and others. But we haven't been able to improve on evidence-based medicine, but this is a challenge for the next research. The data availability, reliance on a single EHR data, and the potential of large language models should be the next and the future work over this one. And this is our publications, and thank you so much for your attention.
Okay, thank you very much. Now it's time for questions.
Request to send, can you move the video button to that corner because we cannot see the slide number to ask the question. Thank you. Can you go to the fuzzy logic that you are talking about? So here you are saying fuzzy logic.
Yes,
right?
yes.
Okay, but if I see the value low, normal, and high, it looks like a categorization. Means if the blood pressure is less than 90, it's low.
Yes.
Okay.
Yes.
So it's 1. You are not increasing the
Yes.
value.
Yes.
Okay. Similarly, if the value is between 90 to 139, it is normal. Above something is high.
Yes.
It is categorization,
Yes.
not fuzzy logic.
So,
Fuzzy logic, if you see the figure, the antecedent, okay?
yes.
The value for each one varies slowly from 0 to 1. It
Yes,
cannot
yes.
be 0 and 1.
Yes. So it.
Yeah. This is more like categorized. If the value is this, I will put normal. If the value is within this range, I will put high.
Yes.
Something like this. So this is categorization.
Yes. So the reverse operation of fuzzy logic can also be a defuzzification, and that defuzzification can also be a binary classification as well. I don't know if yes.
This one is categorization because we are saying if the value is less than 90, it is low. Between 90 to 131, it is 100% probability that it is going to. If something is 91, let us assume my blood pressure is 91.
Yes.
Do you think it is close to normal or close to low?
Exactly. So that is the reverse, actually, or the inverse operation of fuzzification. So the defuzzification will go back to that. So because the fuzzy logic is to reduce actually that fuzzy information and get it close to a certain value that can be given a number. But if you do the reverse operation, you come back to that fuzzy information.
We can discuss later.
Yes.
No, I have published many papers on fuzzy logic, but this is simply categorized. Value is within this range. This is the value.
We needed to consider just the motivation. Why doing this? Because
Yeah, but it's okay. And then I want to ask one more. You are using only textual images in this one.
Sorry,
In your thesis, you are using only textual data.
I used like, let me go back to the scope. So, yes, I used structured data, but also unstructured data. Among the unstructured data, I have text. And among this one, I have like signals and also values.
Yeah, so that is also, signal is also values. So you haven't used images, right?
No, this scope shows actually the stage number 7 and number 10 here are not covered by this research. We couldn't have enough data that was related to this on time to actually include also image.
Okay, that's what I could not see that fine, converting the image into.
Oh, yes, yes.
That's, thank you.
Thank you so much for the questions.
Okay. One more question. Okay, I have one question. So, in NLP processing, you, as far as I understand, you have multiple tasks basically, and ER and the others.
Yes.
So there is no like end-to-end system. You enter the health record and you get some output. Is it so, or I didn't get it?
Okay, so these language models was trained from scratch so that we can have a language model to use in medical area to do the task you were probably talking
Yeah, but
about.
what is the task in that case?
Yes, so in that case, to evaluate the performance of the language models we're using, we evaluated on a benchmark in the biomedical area, and that benchmark has these following tasks.
Okay, so these are multiple tasks that you are basically.
Yes, to evaluate the language models.
So no, it's not like entering the health record and getting some probability of dying or probability of getting better or something like that. It's not this case.
So it's actually not that case. That was a preliminary work that I've done in my master's degree, and I wanted to improve it, and through training from scratch in new language models that handle the challenges we faced in the previous research. And by including images, we'll be able to combine everything and do that pipeline we were talking about.
Okay, thank you very much. So now a few words from the research advisor, Professor Peck.
Okay, thank you for your presentation. In fact, this research is the first biomedical related work from our lab. I think this is because he has a good knowledge in biomedical area. Really, just I focused on service computing and deep learning only, so it's a very good, I think. And from this research, first, as Professor Markov mentioned, the first attempt is improving existing biomedical numerical data with natural language processing. In the case of almost 10% improvement in accuracy. And after then, natural language is very important. So converting the existing numerical data into the natural language using Purdy theory. And last one is just to focus on large language model using big data. So focused on NLP, he showed very good performance. So that's his contribution. So as a conclusion, I think during 5 years, he worked very hard and showed great improvement. So not only biomedical, but also in computer science and especially natural language model. So conclusion is my recommendation is in the future, really now the large language model, especially this large language model seems to be living. So I recommend you to study. You can have a chance to study a large language model. So maybe I hope you can enter into such company to support this large language model. And combining with the last part, image and text. So on large language model, so can provide a very artificial general intelligence. So I recommend for you. So, okay. Thank you for your effort.
Thank you very much. So now it's time for the third presenter.